Welcome to week 4, day 15 of the fall 2024 Programming Fundamentals with C Sharp. This is Jim Kaufman with Rankin Technical College. And today we're going to primarily be going over Chapter 8, both lecture, and I'll go ahead and discuss the labs as well. I guess the first thing I wanted to mention is that for anybody who requested books at, especially the Wentzville office, the books are now out at Wentzville. I know there was one student that wanted a book out of Ashland. I'm going to have to follow up today. I think it's out there, but I just want to follow up to make sure that it was in fact shipped and received there at the Ashland office. So I'll follow up with, I believe that was Hayden, so I'll follow up with him. So yeah, I won't be supplying any more of the individual chapters. No, originally we had a couple PDFs for chapter 2 and 3, and then I actually did some cut and paste. I just did some screenshots of the others, so I won't be supplying any more individual chapters going forward. So anybody who's interested in the book, you can pick that up at Wentzville, or they're available down at the St. Louis bookstore as well. Let me know if you have any questions about any of that. I'll probably resend the email about the Wentzville ones. Probably be best to email the individual who's going to be there, because they don't have a bookstore there, and it's really based on somebody being there available to get the book to the student. So I'll resend that email on the books for the Wentzville. So this week, what we're going to go ahead, as far as assignments are concerned, we're going to have Chapter 8 labs. I believe there's like 5 of them, and they'll be due on Sunday. There will be a hands-on test that I will give you tomorrow at 7 a.m., and it'll be due Thursday by 7 a.m. And also be 2 written tests, one on Chapter 8 and one on Chapter 6. So I'm skipping forward. I'm kind of following the suggested syllabus that the in-person class was doing. They actually skipped from Chapter 6 to Chapter 8, where Chapter 8 is just the arrays and collections. Chapter 6 is a little more involved, so we're going to go ahead and knock out the arrays and collections, and we're going to come back and do Chapter 6 tomorrow. Just a little more in depth, the Chapter 6. So let's go ahead and start looking at some Chapter 8 concepts here. So some of the things we're going to cover here is we're going to be able to distinguish between a for loop and a for each loop. Explain how the array class can be used with arrays. Describe how the null conditional operator works and when would you use it. Distinguish between untyped and typed collections class. And describe the differences between these collection classes, which are list, sorted list, queue, stack, and array list. So here's the syntax for creating a one-dimensional array. So basically, you have to state the type of the array, and then you follow that by open and close brackets and array name. Okay, and the array name is the one that this is user. Whatever you decide to call this name, the array yourself, right? And then you, for the assignment statement, you go ahead and say the length of your array, how long you want your array to be. So we'll look at these 2 examples here. You've got basically an array called totals. That's an array of decimals, right? So this is your type, decimals. This is the name you gave it. And then here you take the name that you gave it, and you specify the length of it. In this case, it's a 4, right? And so you can put it all on one line. If depends on what you're doing. There might be some situations where you want to declare it, and based on some other information that you get in your code, that you decided how big you want the array. But generally, for a lot of things we'll do, just the one statement will be fine. for most of the work we'll be doing. Okay. So here is an example of an array of strings. You call it the name of the array's description. You're stating it's a string array, and the size of that, I'm good at doing that, is a length of 3. Okay. Also, they're showing here that you can create this. You can create 2 arrays in one statement. This can kind of be actually more confusing, but basically you've got an array called prices of a type decimal, and then you also have an array of discount percentages, right? Which is also of type decimal, right? So basically what you're doing here on this is the same as doing this here. Real quick. I think it makes it a little more confusing how they have this here. So basically it's the same as doing this, right? So it's just a shortcut if you're going to define multiple arrays of the same type. So here's the default values for an array. So if it's a numeric array, it's going to be 0. If it's an array of char values, it's going to be the null character. And we're just kind of a quick review, like a char would be the letter A, the letter B, right? These are char characters. There's other characters as well besides just the regular A through Z. But and in this case, the null character is a \0 is the null character for a char. Boolean is going to be, by default, it's going to be false. And a date time, this is the basic standard of the default value for a date time. Okay. And then a reference type. A reference type is when you're referring to usually an object, right? You're referring to an object. And so when you create one that you're stating that the type is an object, the default value is going to be null. So here's the syntax for referring to an element of an array. You have the array name, and then you have the index, okay? So here, right here, this is an example of assigning values to an array. You created a decimal array of the length of 4 with the name totals. And so with an array, it's always 0 based. So when you give it the length of 4, it's going to be 0 through 3. Okay. So the first one is going to be at zero based, right? I usually call this 0 subscript. At totals 0 subscript is the value here, right? At 1, and then 2, and then 3. Now, if you go ahead and try to add one that's outside of the range, which this is outside of, it would throw an exception called index out of range exception. It's because at the fourth subscript, this doesn't exist. It's only going to be 0 through 3, 4 elements. This is the 5th element. You've stated the size is 4. Here, you're trying to add one at the 5th place, right? So this would be an index out of range exception. And I'll show you here in a little bit. I'll show you an example of this and where we can see the index out of range exception. So here's code that assigns an object to an array of strings, where you've got you created an array of type string. You gave it the value of name. The variable name is names, and its length is 3, and you're assigning 0, 1, 2, and these are just all strings, right? So this is showing you, this is another option, and it all depends on your needs. Sometimes you're creating an array from, sometimes you know everything right away when you declare it. And, in a lot of our labs and what we'll be doing, you're already going to know it. But, there's some situations where when you're writing, more complex code and that, there may be some times that you're going to declare an array, but you're not going to know everything you're going to be putting in that array, right? So, but you may, you'll know the size of it, but you might not know all the different elements. Or you may be doing it dynamically, right? But in this case, it's showing you to create an array called totals of type decimal, and then you're basically giving it all the values of that array. So this is a lot easier, kind of a shortcut, a little easier than having to do it on multiple lines, right? Same thing here. We're just taking a look at the ones we already looked at here. And also, here's another kind of a shortcut. You don't have to designate the length of it when you create it like this, because you can actually, it will infer the type of the array from its values. So here you've got four different ones, and it's going to know that, hey, these are all ints, so this is what type it is. Okay, you don't have to say it's a string or whatever. String, int, decimal. It will infer it. Code that computes the average of an array of totals. So basically you define this totals with four different elements, four different decimals. And then you're doing a sum. So you're saying, give me the totals at 0, plus the totals at 1, totals at 2, and then totals at 3. And then you're adding them up and you're dividing it by 4. Okay, that's for the average. The code that puts numbers 0 through 9 into an array. Yeah, so, this is a way to populate array with values. Usually you're going to be doing something else besides putting the number 1 through 10 in it. But, this is one way to do that. Is, you're defining an array with 10 elements, right? And so those 10 elements, got to remember it's going to start at 0 through 9, right? And here you're starting at the 0 for the numbers.length. And so numbers.length is going to be 10. And then you're putting numbers in each one of these. You increment I. So you come in here the first time, this is going to be, I is going to be 0. And then you're going to come here a second time, I is going to be 1, etc. all the way through, right? All the way through the 9th one, right? And then you get here at the 9th one. Well, then you come here, it's going to increment it. It's going to be 10. Is 10 less than the length? Then, you're going to kick out there, right? So here's code that displays the numbers array. Yeah. Yep, just showing it 0 through 9. A for loop to compute the average of totals array. I don't think anything's really, it's just showing you, can you add to the sum, by using, like we've done before, plus equals, keep adding, right? So yeah, I guess the biggest thing is showing that you can populate a variable, a different variable sum while you're looping through this array, right? Okay, code that uses a for statement to display the totals array, yeah, which we kind of already was looking at a for statement. I don't see anything new there to look at. So there is other types of there's another type of for kind of array. It's called the for each loop. And so then for that, to define a loop for this, what you need is, the first thing is you have to state the type it is, be an integer, string, whatever. The element name. So this is the name you give it, right? And then the array name is the name, basically the name of your array, right? that's the basic syntax there. And we'll take a look down here. So here, yeah, it really didn't show. Does it show numbers here? No. So it's basically saying you've got an array of numbers, and the user variable name was number. So you're going to loop through the numbers, every single one of them, right? And then so this number will change through each loop. So the first one, it would be 0. The second one would be 1, etc., all the way through, right? Now, an important point, and I'll point this out later. So something here, one thing that you can do, like when you're doing a for loop here, you can actually, so you can actually change like totals. Let's say totals at 1. You can change the value within your array as you're looping through your array. If for some reason you wanted to change the value of that, you can. But when you're doing a for each loop, you can't change, in this case, you can't change the value of this number. So, that's just an important point. If there's ever a situation where you're looping through and when you get to maybe a certain one, you want to change the value of that, you can't change that. You can't change it using a for each, but you can change the value of a specific element in your array using the regular for loop, okay? Now I will go through that a little more here when we look at some other code here. This is code that computes the average of the totals array. Basically, so you just have to get used to reading this line. Always remember that you have to, the first thing is the type. You have to state the type. In this case, it's a decimal, right? So it'd be decimal or int or string. So here it's a decimal. Total is the name that you give this, right? And it's basically the name of each element. What is the elements of your arrays? Or is it colors? Is it, in this case, it's a total, but, is it numbers? Is it, colors or any, it's kind of it's a user defined variable, and, it should be kind of relevant for what your array is, what's in your array, right? And then in is just, required, that's going to be required. And then totals is the name of your array, like we mentioned earlier. So here's code that uses a for each statement to display the totals array. Okay. Okay, so here is the syntax for creating a rectangular array. And a rectangular array is basically a row and column. It's all about rows and columns. So in this case, you're saying that you've got you're creating a new array of ints that has 3 rows and 2 columns. It's a 3 by 2 array. Okay. And whenever you do in a rectangular array, you kind of want to always define it by doing this. Okay. So let's take a look at this. So here's a syntax for referring to an element in a rectangular array. This is the index values for the elements of a 4 by 4 rectangular array. Zero, 0 is 1, 0, 1 is 2. Yeah. It's just showing you, okay, this is the first, right here's the first one. Here's the second one. This is, you're accessing this one here, this one here. Here you're accessing this one. Here you're accessing this one. And here you're accessing that one. Okay. Well, we're gonna look a little more in depth into into rectangular arrays here. So here this is how you kind of know that, hey, this is a rectangular array. You've got your comma here, right? And this will be important probably within the test too. I know it's going to have a question about rectangular arrays, and I think the comma is an important part of that question. But here's a 3x2 array. So you got a one. So when you've got 1, 2, 3, you got 3 rows, right? Row 1, row 2, row 3. You got 2 columns, okay? And then so the second one is the column, okay? It's a 3x2. So here you're assigning values to a 3x2 array. So here's got a C# and Murdoch's book, and then there's Java, and then ASP MVC. So this is how you're assigning a 3x2 array, right? Another way to create an array of things. Okay. Yeah, here you're doing where it's kind of inferred, like we did earlier. Here you're stating that, hey, these are string. This is an array of strings. Here you're infer by inference that the compilers, the C# compilers, figuring out these are all strings, right? So you can do this. You can do it without stating the type. So here, you use the get length method to get the length of an array. Code that works with numbers array. Number of rows, you use the numbers.getLength of 0. Number of columns, numbers.getLength of 1. Yeah, these will take, you're going to have to play with this a little bit. You're not, it's going to be hard to understand this without playing with it a little bit, right? So, this is referring to the first column, everything's zero based, right? First column, first row. This is the, right? And then, row, column, right? First row, column, and then the second one's row, column, right? Let me look at something here. Right? So always remember rows, the first one, second one's a column. So this is row 0, column 0, which is basically the first row, first column. This is the first row, right? Second column, right? So you use the get length method to get the number of rows or columns in a rectangular array. To get the number of rows, specify 0 in the dimension index argument. To get the number of columns, specify 1 for this argument. So always remember the get length is either going to be a 0 or a 1, right? A 0 for the number of rows, a 1 for the number of columns, right? So here we're just using the get length of the rows. So this is one way to do that. And then here's that products array that we created, or I should say the example in the book. Okay, so that was we're gonna look at some more examples on rectangular arrays. But the other another kind of an array is called a jagged array. And so a jagged array um, can have different lengths. Okay, it could be a jagged array with three rows of different lengths. Okay, so a good way to look at it is, because you're talking like rows and columns. Whenever everything's going to align up with a jagged array, you may have the first row with two columns, the second row with four columns. So that's why it's called jagged, because the second part of that could vary. Okay. An important thing is for a jagged array, you always define it. You always need to define it by putting the number like this. It's always the first one. The second one, since it's jagged and it could be change, it could be different. Then you don't define that. You just define the first one, right? For a jagged array, you're going to do, like in this case, 3, 1, 2, 3. All right. Um, so the syntax referring to an element in jagged array, you got your row index and your column index. So 0, 0 equals 1, 0, 1 equals 2. Code that creates the numbers array. So as you notice here, in one statement. Yeah. So, you notice here you've got one that's got 3, here you've got 4, and here you got 2. And that's why it's called a jagged array, because they're not all even, right? And, we'll take a look at those as well. I think one of the things, really important is, really, starting out, just remember, there are different lengths, right? And always remember that you have to define this first one here. You have to state that first, what the size of that first one is, okay? It's three different ones, right? But in this case, you're saying it's three different ones, but this one has a length of 3, this one has a length of 4, this one has a length of 2. And as you can see here, this one had a length of, right? You can correlate that to this having a length of 3, this one having a length of 4, and this one having a length of 2. Okay. So here you've got string titles, and you're creating a jagged array. So this first one has 3 different items in it. The next one has 4 different items, and the third one has 2 different items, right? And here's another situation where you're using inference. By inference, it's the compilers will decide, oh, well, I know these are all strings, so this is of type string. So you don't have to state it's a type string. If you define it this way, the programming language, the compiler, will infer that this is an array of strings. Okay. Just looping through a jagged array, which kind of could be confusing. So here's, common properties of the array class. Length is very popular. A lot of times when you're looping through it, you want to get the length of the array. That's what you use, especially for for loops. You want to get the length of the array. So length gets the number of elements and all of the dimensions of an array. Common instance methods. So we looked at get length, and then there's also a get upper bound. It gets the index of the last element in the specified dimension of an array. That's the last element. Common static methods of an array class. So, there's some methods that are available, for doing certain functions. And, basically you can copy array. You may want to copy an array, hold on to that copy, and then you know, you have an original array, you make some changes to it, and so that you have your original copy, and then you have a new one. Might be some benefit in that. Um, Binary search searches a one-dimensional array in an ascending order for an element with a specified value and returns the index for that element. Okay, just kind of a search functionality. And sorts probably one of the more popular ones. Sorts an element in a one-dimensional array into ascending order. If you have multiple things and you want to get it in a particular order, when you create an array, it's going to be in no specific order. It's basically the first element, right? It's going to be just how you defined it, but you may want to sort it in a certain way, alphabetically, whatever. And so you can do a sort array which sorts elements in a one-dimensional array into an ascending order. Here's examples of using get length, which we kind of looked at already. So, get length gets the, right here, it's going to get the length of this as being length is 4. Remember, we're always 0 based, right? So the first one, 0 based, here's 0, 1, 2, 3, right? So 4 elements, it's always 0 based. The upper bound. So when you're saying the upper bound, it's basically, here's your upper bound, 0, 1, 2, 3. So this is actually the third element. So this is your upper bound, right? Your length is 4, but your upper bound, you're always 0 base. So your upper bound is going to be 0, 1, 2, 3. Okay? Here's code that uses a sort method. So you've got different last names here. When you're going to sort on last name, so it's going to put it in, basically from alphabetically from, in ascending order. Here's a binary search one. We got employees, got 1, 2, 3, 4 employees here. We got sales amounts. And then we're doing a binary search for employees, Finkelby. So you're basically saying, hey, find me within this array, here you got a very small array, but it could be a very large array. And so basically inside this array, find within the employees array, find me Finkelby P and give me the index for that. Okay. And then by doing that, you can also get the sales amount. That's also, so this is called what's called, and you're going to be doing this a little bit. We're going to do what's called a parallel array, where basically you're going to be setting up some arrays where you'll have a name. The first thing, this name is at employees.0, but this is the sale that's associated to this. And basically, so you're saying employee.0 is this. Sales amount at 0 subscript is going to be this one. So 0, 0. And then here, this would be the one at at 1, right? At the subscript 1 would be Finkel P. Same thing for sales amount at subscript 1. This would be the sale amount. So this would be at 2. And this would be at 2, subscript 2, and this would be at subscript 3, and then you associate it with this way, okay? So this will be something we'll be doing, and we will look into this a little more. So, this is going to be what you're going to be doing a lot, and, some of the hands-on tests and also the labs where you'll have multiple arrays, but, you're going to be associating those arrays basically by index that you're going to line everything up. so that the first array and the second array, it depends on the subscript you're using. You'll be able to line them up, okay, to get the values you want. This is creates a reference to another array. Yeah. So yeah, this is important to know. Yeah. And we're going to go into this a little more, definitely a little more, especially because when a lot of times we always think about values and that. Um, and so a lot of times you have a value and, you know, when you assign one, if you have an integer of say 5, and then well, let's say here, let me just do this real quick. So let's say you do an int x equals 10. Yeah, sorry that it's going to make that capitalized like that. We really don't want to capitalize, but let's say you have that, and then let's just say we got another one. Well, let's say we're just going to do y equals x, right? And then if we change, I know it's always going to make these capital, y equals x. So now that y equals 10, right? So, but if you take y now and you set y to say 20, right? So originally you had x equals 10. Then you set y to x, which is 10. Now you changed y to 20. The value of y will be 20, but the value of x will stay 10. Okay? So that's kind of because you're setting it to a value. You're not setting, it's done a little differently. Whereas here, when you create this inches array and give it these values, then when you did create a new one, a new variable, and set that to this one, if you change this one, it's going to change. It's because of how it's stored and stored by reference. And since it's stored by reference, it's pointing to the same thing in memory. Whereas integers and stuff like that is handled differently, right? It's kind of by value and not by reference. So that, when you do that, like we showed that x and y, right? That won't change the original one. Whereas here, you're actually changing your point. You're just saying, hey, point to this. When you say reference, you say, take this, here's a new variable, point this to this one. And so when you're doing that, whatever you change in that, you're actually changing it at that place in memory, so that inches 1 and inches 2, whenever you change something here, it's going to reflect here as well. Okay. Hopefully that made a little bit of sense. Don't worry, we're going to go through that some more. Code that reuses an array element. Okay. Yeah, it's just showing here that you can actually reassign it again. Sometimes for copying it. Okay. I don't want to go through things that I think will confuse you too much. I probably confuse you enough as it is. A statement that creates a null array. So yeah, so you can always define an array as null from the beginning, and later decide what you're going to do with it. But if you ever create it as null and you accidentally tried to refer to it in some way, as you can see right here, Here you got initials, and you're saying give me the element at location 0. It's, subscript 0, location 0. You didn't, you never, you declared it, but you never initialized it with values, so you're going to get a null point. You're going to get a null reference exception in that case. Okay. So yeah, so this is one way to. It's showing you, here's one way to avoid that exception, is basically by asking if initials is not equal to null, then you go ahead and do it, right? So you don't do it unless it's not null. So that's one way. And then this is uses null conditional operators to prevent it. So here's another way that you can actually do this, is by putting question marks like this. Okay. And by doing these question marks, this will prevent you from also getting a null reference exception. Okay. So here you want to put it anything that would cause a null pointer exception, which is basically trying to access a 0 element. That's going to cause a null reference exception. And also, even if this existed, what's exists at this location still could be null. Okay. You might have put a null, you could have initialized that very first element, right, at the 0 location as a null itself, right? So then this would actually still be okay, but then when you try to do 2-upper on it, you can't do 2-upper. 2-upper is for a string, and you can't do that on a null. So in this case, you're kind of protecting yourself in two different situations of possibly getting a null reference. One is if you even initialized it at all, right? And then the next one is to make sure that what you initialized it as was not a null. I'm sure that kind of a little confusing there for you too, but you could basically do something like here. Let me see. And, especially when you're doing something maybe dynamically, there might be, a lot of times you wouldn't maybe do this as, in the labs and the assignments that we have, but, sometimes you're building these things from other data. And when you're doing that, there's possibilities. Some of these could be null, right? So like I said, by you defining this, you've actually, this is a good value. This is now initialized, right? And so this right here, actually, you wouldn't even have to even test this, but it doesn't hurt, because basically you've went ahead and initialized this. So this is not, right? So wouldn't even have to worry about it now, but so this is initialized now. So that's not going to be a null exception, but you assigned it a null variable. So when you try to do 2-upper on this, you're going to get a null reference exception. I hope that makes a little bit of sense there. It's an array that used the following examples. Okay, it's just showing you a way to refer to an element from the end of an array. I'll have to look at this. I don't know why. 0, 1, 2. I think that's right. I haven't done this much, and it's been a while. I need to look at this. I think it's because this is 0, 1, 2 here. I don't know. Second one from the end. 0, 1. I'll have to look at that. I have to take another look at that. How to refer to a range of elements. Oh, yeah. So this is one way, to refer to a range of elements. So here you're basically saying, Index is 0, right, through 2, right? So we're always 0 based. So 0, 1, and 2 is 3 elements. Here, you're basically saying the same thing. Well, from the start, including just an ending index, right, would be dot dot 3, including just the ending index. By including just the starting index, okay, here by including no starting or ending index, and this could be 0 through 7, yeah, basically everything. And this is by including an index from the end of the array. Index 3 through 5, 3, 4, and 5. Yeah, so it's counting backwards too. So that's, yeah, I got it. So when it's 7 length, it's going to be from 3 to the ending. Okay, got it. I still think it'd be a good idea for me to refresh my memory and go through that a little more. How to use an arrange. So here, yeah, you're doing basically, before we were just looking, most of the times when we did this, when we looked at this for each loop, we just put in the array name, right? The array that the name of the array, or, in here, right? And here it's actually, stating it just wants to go through certain parts of that array, right? Indexes 3 through 5, so that you don't going through the whole array. You're just going through parts of the array. Okay, how to use an index range. Okay. So do want to kind of really go through. So we have there's this thing as arrays and there's collections, and so um, arrays and collections are similar. They both can store multiple elements, which can be value types or reference types. Okay. One way that arrays and collections are different. An array is a feature of the C# language. Collections are .NET classes, and they're kind of just some special classes, built-in classes that you can use for different collections, right? Different groups of data. Collection classes provide methods to perform operations that arrays don't provide. Arrays are fixed in size. You're defining your array, either by putting the number of elements in the brackets, or using the curly braces and actually stating all of your elements in the array. But collections are variable in size. You don't have to define it. You can just add to it, remove from it. Okay. So some of the common use collection classes are a list, and when you see these brackets like this, these mean certain things, and I'll probably need to get that for you. So basically, T stands for type. All right, T stands for type. So is it an integer? Is it a string? Right? It could be, and also you could create your own user objects. And so, like let's say we created a car object, and so you could have a list of car objects. So it can be, different types, right? But you have to define what kind of type it is. And then here a sorted list. For a sorted list, it's showing you use what's called a key value. These are key value pairs. It uses key to access a value, which can be any type of object, can be inefficient for accessing elements. Yeah. 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 It's just saying it can be very inefficient for accessing elements sequentially in order, but it's very efficient for inserting elements into the middle of a list. So sometimes a lot of these different collection classes are about, is something more efficient, is it quicker, especially, when you're doing some very, very serious, significant type of programming where you might have a collection of, thousands of items. And so, when you're having to go through, like do some, like, we were doing a for loop, but if you have to go through a whole long list sequentially to get this something, right? Um, you know, that's not very efficient. Whereas when you've got a key value pair, you can say, hey, give me this key, give me the value using this key. That's much more efficient, right? And it's easy to insert things or do other things with that to call, to be able to access it or insert new things. So we'll look into that as we go along here more. Other collections classes, there's queues and stacks. A stack, and you notice we got that whenever you see this T, that means you're going to define some type here, right? What kind of type of queue is this? Is this an integer? Is this a string, right? Same thing with a stack. So a queue uses methods to add and remove elements, and it just says, and the same thing here for a stack. Well, we're going to go through these a little more, both now here and then also we're going to look at some more code and for these. So I want to kind of point out, so mention this, maybe a couple times here. So queues are basically first in, first out. So the first thing you put in, the way the queue works, it's a first in, first out, called FIFO, right? First in, first out. And so you think of a queue as, you might have a music queue. And so you put something in this queue, and then the first one you put in is what's going to play. And then you keep adding things, and it's going to be sequentially. So the first one in's, the first one out, the second one's in, the second one out. It's called the first in, first out, right? Philosophy there. Now a stack is different in that it is a last in, first out. And stacks are used a lot in like actually in programming for, within using the language itself. So like when you've got an error, let's say you get an error. So, when you run a program, there's all these steps of things that happen. It loads these libraries. It initializes variables. It does all these steps. When you're in Visual Studio and you click that button to run that lab, when you click that button to run that lab, a whole bunch of different steps happens, right? It brings in your systems, all of the systems you have defined. It brings in, it defines the variables. It does, all kinds of different steps, right? To actually get to where it runs that program. And so a stack will, in programming, a stack actually tracks all that things, tracks all those different things that happen. So when you get an error, you're not really worried about that first thing that happened at this point. You may have to go back and you might have to go from that error back a little bit, but you don't really care about all that beginning stuff. You want to know when you got that error at that point, because that's the thing you're going to look at. Oh, I got an error. What's that exact error? So on the stack, that's the last thing, right? It's, the first thing was, loading all the system libraries, then, doing all these other things that the program does, initializing variables, etc. And like I said, there's a whole long list of things, but when you got the error, that last thing that happened is what you care about. And so your stack, you want to see that last thing. That's what's important to you. So that's kind of last in, first out. And we'll look into that more. That's not the only purpose of that, but it's kind of kind of explains it. You're just worrying about what happened last more than you are worried about happened first. Okay. So, because you'll hear about stacks, especially when we talk, the more you get into programming, you'll hear about there's a stack, right, within programming as far as executing of an application, right? Let's see. So let's go ahead. It's 9 o'clock now. Let's go ahead and come back at 9:15, and we'll continue. We don't have, there's a little bit more. We were not going to cover everything in this, but we'll go ahead and finish this, and then we'll go ahead and look at some examples, and then we're going to go through some labs. We're not going to go till 11:55 today. We'll just see where we're at though, but we're going to start. We'll stop way before then. So, yep, go ahead and come back at 9:15, and we'll continue on. So here we've got a what's called the untyped collection, right? Here's code that uses untyped collection. So basically, you're just creating a new array list, and you're calling this numbers. You didn't state what kind of type it is, so you can add here. You're adding to your numbers array. You add a 3, a 7, and you can add a test. It'll allow you to do this, right? This will compile, won't be a problem. But when you go ahead and run it, it will cause a problem. It causes a runtime error because it's thinking that these are going to be all ints, and then you put a string in here, and so you're going to have a problem in here. Well, you're going to have a problem when you try to, I should say this, when you try to assign this to an integer is where you're going to have a problem, okay? It'll compile fine, but if you end up trying to treat this one that you added text as an integer, you're going to have a problem, right? And so here's an example of a type collection. And so, also you're going to have to make sure when you're using these different collections that you actually do use the correct using thing here. It'll prompt you within the editor to add things, but you just want to make sure that there's additional things you'll have to use at the top. System libraries you'll have to include, right? So here you've got a type collections where you defined it as an integer, right? So since you did it as a type collection, you add the number 3 is fine, 7 fine. When you try to add this test, this isn't integer. You define this as an integer. You're trying to add a string, and this will be a compile problem. And basically within the Visual Studio, it's going to be underlined in that red because it'll let you know that it's a problem. So this is just showing you, here's a list of string elements. Here's a list of decimals, a list of strings with the capacity of 3. So in this case, so a lot of the stuff in elements, using these collections, you don't have to tell it the capacity, but some situations you may, and here you're actually you're giving a capacity of 3 here in this situation, and this is how you would do that. Okay. Common properties and methods of the list class. So you have the index. It gets or sets the element at a specified index. The index for the first item is always 0. Then there's these other ones. Capacity gets or sets a number of elements a list can hold is the capacity. Count gets the number of elements in a list. Okay. So when we're saying properties usually you're not going to have the open and close parentheses. Usually whenever you're here, when you see it with no open and close parentheses, this is talking about properties. Okay. These are certain properties, not like we were looking at that length, right? That length is a property. Method. And a lot of times, one way to look at it, usually a property is giving you information about something. Proper capacity, it's giving you information about it. What is the capacity? What is the count, right? It's kind of information about it, right? Usually properties are going to be that. They're basically providing information. Where methods usually are doing something, right? Methods add, right? Adds a method. Clear is a method, right? These are, and they're kind of more action words, right? So here's the method add, adds an element to the end of the list and returns the element's index. So it's just telling you it'll return that. So basically you can, if there's any reason you want to know what the index level is, once it adds it, it returns it. It'll just return a number. You may not care about that, but I'm just, it's just telling you that it actually does return something. That can be ignored, or, maybe there's a reason that you do want to know where it added that at, right? And then clear removes all elements from a list and sets its count property to 0. So clear is basically going to clear that whole list out, right? So here's some more methods, right? Returns a Boolean contains. Does this contain? Returns a Boolean value that indicates if a list contains a specified object. Here is an insert. Inserts an index into a list at a specified index. Removes the first occurrence of a specified object from a list. Yeah, so here removes the first occurrence. Yeah, so you have to make sure when you do remove something, if you want to remove one out of a specific place, then you need to make sure you use an index. If you just use the remove, it's basically going to just remove the first occurrence in the object, right? So the very first item in that array, that collection that you created, that list array for the list, very first one, it's just going to remove that. If you want to remove one at a specific place, you need to make sure you remove that and use the index for that. Binary search searches a list of specified object and returns an index for that object. So this will, usually when you can have multiple objects, like we kind of talked about car objects, you have multiple car objects, and then it would search that whole list for a specified object, of a certain type maybe, and then it would return it and returns the index for that object. Sorts the elements in a list into ascending order. We're going to look at a few more here. Code that causes the size of a list of names to be increased. Okay, yeah. So here it's telling you basically you have a list of 3, 1, 2, 3. So one thing that we kind of seen before, this is kind of different. Whereas, with an array, you defined the size, the size of an array, or you gave it a bunch of elements that define the size of the array. So if you try to add another element, you've already kind of defined the size. You can't do that, right? So it's more static in nature, where once you define it, that size, that's the size of it. Well, that's different here with collection, especially this list one, right? So here you're giving it an initial value of 3. So here's the first one, and obviously this is always at the zero index, right? And then here's the second one, and here's the third one. And then what happens is when you add another one, you can add another one. So this is your fourth one, and what it will do is this actually number, instead of just adding another one, it actually creates. In essence, it's changing this to a 6. Once you do the next one, it's going to create 3 more. Then when the capacity is doubled to 6, and then when you come down here and you get to the 6th element, you add another one after the 6th element. It's actually going to double this again and make this a 12. I'm not saying you're going to see this number change. I'm just saying within memory, that's what it's actually doing. it's going to always double the size. Right? Once you reach the max and you add another one, it's going to double the size of that array, and then will be, empty, elements that you can keep adding to. So, syntax for retrieving a list, a value from a list name index. Yeah, pretty basic here. You're pretty much doing the same thing. You're just grabbing the first one, subset, subscript 0, and that's the very first one on the list. Nothing fancy there. Code that inserts and removes an element. So here, you're inserting a new first element. So you can say, hey, I want to change that first one to a different value. This is a way with collections that you can actually, you insert at 0 this value, and it's going to replace what currently is at that location. Okay. Sales totals. Sales 1. Sales 2 is sales totals at the first one. Well, here, it's showing you doing a remove. And this will remove the one at subscript 1, which is basically the second one in the list, right? It's just showing you the values of these. Okay. All right, let's see. Code that checks the first element. This is going to be important for some of the labs and stuff. We're going to be using contains. If X contains X, if sales totals contains X. So yeah, we'll be doing using this contains. So we'll have different arrays. And then you're going to be doing a search, and then you put, something in your WinForm search box, and then you're going to be using this contains to search your array. Obviously, it won't be sales totals; it'll be something else, right? But you'll be searching your array for a value that you put in the search box. So we'll be using that quite a bit here in some of the labs and homework, the hands-on test. So I do want to point out, so this is called a sorted list, and a sorted list, so what you can do with a sorted list is you give it the key, and it's going to get or set the value of that element within the specified key. So basically, you got keys, values, capacity, count. So with keys, it gets the collection that contains the key in the list. Values, it gets the collection that contains the values in a list. So when you've got a key and value, if you just want all the keys, you can ask for all the keys, and it'll give you all the keys. If you want just all the values, it'll give you all the values, right? It's a property, and capacity and count. Let's see what else. Properties, key. The key of a sorted list item, that's a specific key. And then a value associated with the key, that's a specific value. Let's see here, how to create and load a sorted list. So it's just creating a sorted list. So what it's doing here, the first one is going to be the key, and the second one is going to be the value. A lot of times you would say for a lot of things, especially when you're using keys and values, you can use strings as keys, that's fine. But a lot of times, and I'm not sure about every lab what they're asking you to do, but a lot of times when you're really doing what's probably best a lot of times for a sorted list is your key being like some kind of a numeric number or something that's, very, because sometimes you could have, when you're using strings, as long as the strings are some kind of basic strings, but when you're using names and sometimes there might be some commas in there, some other type of things, strings can pose a problem sometimes. And in this case, it's showing, not that you can't do it. In this case, it's showing you, here's your key. It's basically the first name dot last initial, which is, this is fine. I'm not saying it's always wrong, but a lot of times you always think of a key as being something that's an integer or a number or something, or a string, but some kind of basic string. Where you're not going to have a full name being a key. It usually is not a good idea, right? So, but in this case, you're using a string for the key, and then your value is the decimal. So this one, when you've got two different arguments here, the first one is your key, the second one is your value. So your key is this, and here's your value. Okay. So here's with an initializer. Yeah. So this is one way. You basically declare your list, your sorted list, and then you use the .add to add to it. In this case, you're doing it kind of all in one step. You do the shortcut. It all depends on how many items you have and how you're populating your list. If it's 1,000 items, you definitely don't want to do it this way, right? You'd have to find a different way to do that, right? But in this case, you just have 4 different ones, and you're just creating a initializing variables for your sales list here. Let's see what else is here. All right. Yeah, we'll have to look at some examples of this because, so don't want to confuse you on some of that. So here's a queue. And like I said, the important thing about a queue is, remember, it's a first in, first out. So, you're, like I said, I kind of use the music queue as an example, songs, and so you keep adding songs to that queue, and the first one you add is the first one that's going to get played. Second one you add, second one, right? And so use here's a property. A property is count. It gets the number of items in the queue. Here's some different methods that are available. And the first one will add in queue, adds the specified object to the end of the queue. Here's DQ. This gets the object in the front of the queue and removes it from the queue. Okay. So the front of the queue, and this one's the end of the queue. But this one, you got to realize, here you're adding, and here you're removing, right? And then you got clear, just removes all items from the queue. And then peek returns the next item in the queue without deleting it. Okay, so, maybe you've got this big long queue of songs, and you just want to show, you're playing one song, you want to show the next song that's going to be coming up next. You're doing a peek, so that peek will show the next one that's in the list, right? The next one in your queue, I should say. Okay, get too far into all that. And then here's a stack. And, kind of like I mentioned earlier, there's different ways to use stacks, obviously, but, and it's not, we'd probably do too much in this class, but, it is important, it's really important in programming languages, because all these different languages like C#, Java, etc., they all have this idea of a stack, that when you're doing execution of a program, that, like I said earlier, the first thing that, when you load all the system library, there's all these little steps that have to take place when you click, especially when in Windows, in Visual Studio, when you click that lab to start that thing up, you're going to have all these steps that are going to happen. And then, so it's basically a stack, and it's from, all the way from the beginning of the execution till the current state of the execution. And like I said, if you get an error, you want to know, you don't really care what happened at the beginning so much, right? You want to know what's happening right now. I'm getting an error. What's the error now? And then you can actually look back at the stack saying, okay, here's the error. What happened before that and happened before that? You go reverse chronologically, right? You reverse where you want to see what happened right now, and then keep going back until you can figure out what may have caused your problem, right? Just an idea. Count gets the numbers of items in a stack. Push adds the specific object to the top of the stack. Pop gets the object at the top of the stack and removes it from the stack. And then obviously you got clear and peek, just like you did for the queue as well. So it's just showing you an example of doing a pop here, a push and a pop. Push to add them, pop to remove it. All right. I think I think we'll go ahead and stop on this right now. I'm going to go ahead and go through some code here, and I think we'll go ahead and go through use Visual Studio. So here's some code examples. We're kind of looking at code examples. It's just a little cleaner looking within the IDE here as opposed to just in a PowerPoint. So this is just a big long static, big static main method with a whole bunch of different examples in it. Okay, and then over here on the right, this is just printing everything out. So here, and some of this is going to be kind of we talked about a little bit. We're going to show it a little more, and it'll be a little bit of review as we're going. So basically, this is declaring a one-dimensional array by stating, putting the type and then open and close brackets. Here's the name, the username that you decided to put it, developer name that you decide to put it, and call it numbers. And then you use the new keyword and a new int, and here's the length of it is a 5, right? You're saying you want a new array of 5 elements, right? And then here's how you can assign elements to that array by doing numbers at subscript 0, at subscript 1, 2, 3, 4, adding numbers, right? So then let's look at what happens when we try to do something like this. So let's just do that. And as you can see, the editor didn't complain or anything on that, right? Now let's go ahead and rerun this. And then here is your index was outside the bounds of the array. So this is a runtime error, right? There's a difference between a compile time error and a runtime error. And in this case, the editor does not figure that out, and it's not a compile. This doesn't happen at compile time. This is a runtime error, right? So this is a runtime error, and this is your sysindex out of range exception. Okay, so you cannot do that. Stop that. Now you can go here and let's just change the first one in the list is a 10. Let's make it a 15. And let's save that. Now let's run this. And then you can see here, I know it might be hard for you to see. So the first one on the right here, item 4, this one-dimensional array. The very first one is 15 now. We changed the value of 15. So it will overwrite the value, right? Started out as 10. We wrote it with 15. So that's that. And this is just, basically what we're just looking at here. I'll just run it again, get rid of the 15. So we're back to 10, 20, 30, 40, 50. And this is just how to work with arrays. You're just looping through it. You want to use the dot length, right? Always have to be here like this capital L, right? And like I said just a little bit ago, this is called a property, right? This is a property. Usually when you're talking about methods of a, methods of a collection or a thing like that, you're going to see the parentheses, right? Properties are, just giving you, basically properties is usually about giving you additional information, right? So this is giving you, what's the additional information is giving you about your numbers array. What's the length, right? So that's the additional information it's giving you. So that should be pretty basic. Then obviously you have to remember it's zero base, so you're going to always have to start with a zero. How to use a for each loop. Okay, and so like to review on this, your array was numbers. Okay, and you always have to use the in here, and you have to define what type is your array. Your array is a numbers array, so you have to define that. You're basically defining what this is going to be, actually. And this is, user created. This is whatever number name you want to give this. You could, right? You could call this num, but you're going to have to change it here, right? So this is user created variable, whatever you want to call it. But, you always have to have the type, and you have to use the word in and use numbers. Now, one thing here that you can do here, so here, let's just run this. I guess it's already ran right over here. So it's 10 through 50. One thing you can't do here, you can't do like something like this. So number, right, 0, like we were doing up there. Well, help if I use the right. See, things like that won't work. It doesn't, that won't work. Well, even it's going to tell you you can do that, but see, it's a compile time error. Cannot apply indexing. You can't change this value. You can't change this value like that, right? Even there, right? You're saying this is an integer. You're just trying to reassign it. You cannot reassign a num because it is a for each iteration variable. So, something to point out here is you want to make sure that you're ever looping through something, and the purpose, something you're wanting to change within that loop, you cannot do that, right? Now up here, obviously you can change this. Well, we didn't actually do that though, but let me show you this. So you got your number 0, right? So we can change this right here and just say, let's do this, and then, no, I don't want to do it like that. So we're going to change this second one in the list, which is that subscript 0, and we're going to change that one to a 25 instead of 20. Save that. We're going to run that. And as you can see in our list, the second one is now 25, right? So you can change the numbers as you're looping through this. You can change the numbers when you're using a regular for loop. And I would call this more like a traditional for loop, right? Some, for each is it's been around quite a while, but for loops, predated all these other kinds of loops that are available. For loop was pretty much the very first kind of loop that was created in most programming languages. So for loop is, I would call it traditional loop, but this is a for each. Obviously, it came after that one. But we'll get rid of that. But just making sure, I want to point out that you cannot change your elements in a for each loop. You can't change your elements like you can in a regular traditional for loop. So here you can always tell, hey, how to work with. Let me see what comments I put in here. So for a for loop, you need to access the index of an element with a collection while iterating. Elements during the loop. While for each is preferred when you simply want to iterate through each element in a collection without needing the index also, or modifying the element within a loop, So, because sometimes you might, for some reason, you might need the index of what something, at that point, what that is, and you won't have that index either in that for each loop. So here, one thing to always notice, how to pick out, hey, I can tell just by, without having these comments, this tells you it's a rectangular array. If you have this, comma here, one or more commas, this is a rectangular array, right? And this is a rectangular array of 2 rows and 3 columns, okay? And this is how you assign values to a rectangular array. So the first one, right, is going to be the row. Second one's column. So at row 0, column 0, you add a 1, etc. So up here on the right, which one is this one here? We're printing stuff out on 9. So it's showing you, yeah, in row 1, column 1, row 1, column 2 is a 2, row 3, right? Row 1, column 3 is a 3. So, and obviously it's always 0 based, 0 indexed, right? So this is how you actually, not to confuse you here, but this is how you can go ahead and you do in a for loop within a for loop, and this is how you can make sure that you print this out rows and columns the correct way. This is item 9 here. So, and for item 9, to be able to print this out, this is how you would do this. You do different variables, an I and a J to print this out. Okay. A jagged array. So how to tell something's a jagged array? You declare a jagged array. Here you're declaring it with 3 rows, right? So you're saying the first jagged array is going to be a 1, 2. See, there's different. They're not all the same. This is a 1 and a 2. This is a 3, a 4, and a 5, and this one's a 6. That's why they call it jagged arrays. They're not all the same. They're not symmetric, right? Different. So it takes time to get used to this. I don't think we'll be doing a lot of that. A lot of the stuff we're going to be doing is pretty much going to be rectangular arrays, but just be aware that you also have the jagged arrays. Okay. How to assign values to a jagged array? Yeah. Okay. More skills working with arrays. Yeah. Okay. So here, let's look at this. Copied array, item 15. Here's your copied array. 10, 25, 30, 40, 50. That's using the numbers from earlier. Actually, it's probably changed because I probably changed it. 10, 20, 30, 40, 50. So you copied it, and then you're just looping through your copied array. Here, you got totals 2 and 3. Yeah, I don't know if there's anything I really want to look at too much there. How to code methods with arrays. Well, we haven't done too much with methods. This is actually a method. We'll probably skip that for now. How to use non-conditional operators. So here's that situation using that non-conditional operator. So we got a string array called words null, so it's null, right? And even if you don't define it as null, it's going to be null. It's going to be null anyhow by default, right? But here, yeah, you're using, this is basically saying, so if this prevents this from happening, it prevents this from happening by having that question mark saying, hey, if this is null, as long as this is not null, then you go ahead and grab the 0 thing, right? Um, so, and this is basically telling you to print that out. So let's do this real quick. So this is what, 18 here? 18, first element, if not null, array is null. Yeah, so basically, if the first element is not null, then you print, then you use that one, right? So if it's not null, you do this. Otherwise, you're going to print this out. Array is null. So a lot of times, sometimes there's other default values. This is just doing array is null. Sometimes you might have some other kind of default value. If something's not, if it's empty, just put a 0 in it, and you could just put a 0 here. It would treat it as a 0. But if you don't have this here, compilers already tell you words may be null here. It's just letting you know that this may be null. We save this and run this. Throw an object reference not set to an instance of a type. Words was null. Right? So, and the other way, kind of the older, this is very handy. Years ago, let's run this again. Years ago, and I'm sure that, a lot of you, when you get out in the workforce, you're going to go into, and it doesn't matter really what programming language. You're going to get out there and you're going to look at code and it's going to say, if this is not null, do this. If that, you're going to see all kinds of if-else statements doing with nulls. Some places did things a little better, did handle that better than other places. Different, and I shouldn't even say places, projects. Sometimes when you're working somewhere, one project can do things a lot different than another project. Teams do things different, right? There's, so many different variables. It's not like everything this one company is going to do it the same as, and everybody in this one company is going to do things the same. Team, everything is varied depending on team, project, and everything else. But, there's always legacy code, that hasn't used newer features, and there's always legacy code in any kind of a newer, older companies, right? And there's going to be legacy code, and especially you're talking about bigger companies, financial companies, all your different banks, Bank of America, Chase, talking about like MasterCard, Visa, all these different financial organizations. They've been around for a long time, and they've got all kinds of legacy code. And what you'll see in a lot of them, you'll see a lot where you'll have if statements checking to see if this is not null, then do this, else, So, using this kind of null condition operator, these question marks, it's very very helpful. It makes things a lot easier than having to put all those if else's all over the place. Here, commonly used collection classes. So this is just telling you type a string, right? For this list, here's a John, Jane, and Tom. Here you're doing a for each names. Always remember this is your own variable that you decided. And this is only available within the scope of this. You leave your for each statement. This name is only available within the scope of the for each. You get out of that is not available anymore. Obviously names you have defined up here, so names is still going to be in scope. You'll still have it be outside the for each loop. You'll have access to that, but the name itself, that's once you're done with that for each loop, that's gone, right? And always remember, for name, you can't really change the value of that within the loop like you do on a for loop, on a regular for traditional loop. How to work with a list. So here you already got names. You added that. And then now you can add Mary to that list. Let's look at number 23 here. So even though, before, how we did the regular arrays, these are collections, right? The list and the array list and the sorted list, these are all part of that collections library, right? It's a built-in library that C# makes available. But you can add another element, right? We've seen before, like when we initialized when we initialized data for our arrays. Once you initialize it, it would have 3 elements and that's it. You try to add another one, you're going to get an error, right? But in collections, that's different. So here we're taking names, we're adding Mary to it. And it's just showing you Mary being added to the list. And then here is a sorted list. Here's a sorted list where you're adding these at different times. Well, for sorted list, what you have here, remember, sorted list is always key, and a value. Your key, and here in this case, it's an integer, and this it's a string, a type of fruit, right? And so this is how you have to set that up. Well, in this specific situation, right? So then you add 2 a banana, add 1 apple, add 3 cherry. When you go ahead and print these all out, it's going to be in the correct order: apple, banana, cherry. So the sort is based on your key, right? It's going to sort it based on your key, right? How to work with queues. Here's a queue. What do we have over here? Popped element from stack. Item 25. DQ'd element from Q1. Yeah, so here, you're basically DQing this, right? Removes the first element. So this is always going to be the first element. So you actually remove that first element. It's just giving you numbers, 1, 2, 3. You define it with an int. So this can be 1, 2, 3. It could be defined with other types as well, right? But in this case, this is an int 1, 2, 3. And then it's basically saying, let's do a DQ on that. And when you do a DQ, it's going to remove the very first element. Okay, this one here is a stack where you're doing push. For stacks, you do push. You do a push for C programming and a push for ASP.NET Core. And then you're doing a pop to remove it. So pop removes the last added element. So remember, like we always said, for queues, it's first in, first out, FIFO, right? First in, first out. So when you do a DQ on a queue, you're removing the first element, first in, first out, first, right? When you're doing a pop on a stack, right, it removes the last added element, last in, so it's LIFO, right? Last in, first out for stack. How to work with array list. Let's see, we're adding a 1. So here you're adding different types, right? And so 26 here. So for an array list, you can just add different types. They don't have to be the same. Now, it's only if you decided to do something with this item. If you tried to treat the second one as a number, you're going to get an error, right? If you loop through this and you try to take this to add, to do something, multiply or whatever with this item, when you're looping through here, you're going to have a problem with that, right? But sometimes sometimes there's array list, you just have an array list of all kinds of different things. That's a possibility, right? Different types. just showing that you could go ahead and do that with an array list. Parallel arrays to store student details. So here's a situation where, and so we're going to be doing some of this within the labs and the hands-on tasks. So here's a parallel array. So basically, it's actually 3 different ones. So basically what you're doing here is you can access, you got John Doe, Jane Smith, and Alice. You got 3 here. You got 3 student IDs and 3 phone numbers. So for some of these labs and the hands-on tests, we're going to associate this one, the one at 0 index student names at 0 is going to be John Doe. Student IDs at 0 is 101, and then phone numbers at 0 is going to be here. So you're going to be associating John Doe with 101 and then this phone number. The second one will be Jane Smith, 102, and this phone number, okay? And et cetera. And so this will be, you'll be doing some of this with parallel arrays so that you can, just one way, it's just one way to do this, and kind of with the example within the labs and things. So just understand what you're doing there. You have different arrays, and you can use that just by doing the subscript at the the location in each array to put them together, so to speak, right? So display the student details. Yeah. Let's see what we have here on that one. That was after, I don't think it's numbered, 26. Yeah. Student John Doe, ID, phone number. So yeah, there's your, so this is what you'll be doing for some of the labs and the hands-on test. And so I think that's about it. And here's that array we were accessing earlier. We decided to skip that one. So that's that. What else was I wanting to do here? Let's look at, so we're kind of doing, we're kind of doing things a little bit over and over again, just, because, there's a lot here. So I'm going to provide this. I need to look at this and see, I might want to add some things, but here's just kind of a study guide. This will be the study guide for the Chapter 8 written test. And so, what are arrays? Arrays are ordered collections of elements of the same data type, right? So that's really important to remember, same data type for arrays. We just looked at an array list where you can have different data types, right? You could add any kind of data type. Declaring and initializing array. You can declare an array using the square brackets after the data type and specify the size within the brackets. You can initialize an array with values during declaration using the curly braces, right? And here's an example of that. You created a array of numbers and you gave it the numbers 1, 2, 3, 4, 5. Make sure you're using curly braces. Sometimes you can get confused and people, might try to use brackets here. You need to make sure you use the curly braces when you're assigning values like this, right? Accessing elements. Elements are accessed using their 0-based index within square brackets. Example, number 2. Numbers at 2, at the location in 2. Accesses the third element, which is 0, 1, 2. Accesses that, which is 3, right? Rectangular arrays. Arrays with rows and columns. And you declare using commas separated by square brackets. And you want to put that comma right in there in that square bracket. And so here's an example of a string. This is row 0, the first row, right? First row, first column, right? And etc. So jagged arrays are arrays of arrays where each inner array can have a different size. And just remember, we won't do much on the, you ain't gonna have to worry too much on this, but you're gonna need to know this a little bit, at least just for the written test. So just remember, whenever you you define a jagged array, you need to make sure that you want to say the size of it. The second one, you don't know. This is the one that you could have 3 elements in it, 2 elements, 4 elements, right? But you do define, in this case, you're defining 6, right? 6 is, so collections are more flexible than arrays. Yeah. So here, just remember, there's several built-in collection types in the C programming language. Here's a list. Remember, T stands for type. So when you create a list, you want to put the type. Is this an integer? Is this a string? It could be a lot of different things. Well, once we start really looking at objects, could be a certain kind of an object that you'd put in there. Same thing with stack. You need to put in a type. Same thing with queue. You need to put in a type. For a dictionary, which we really didn't look at much, but a dictionary is basically a key value pair, right? Key value pairs for a dictionary. Kind of same as sorted list. I guess we looked at key and values for the sorted list. Dictionary also has what's called a key and value. And so here's your type key and your type value. Typed and untyped collections. So a type connection specifies the data type that can hold during declaration, right? Prevent runtime errors by ensuring data type and consistency. So when you're using a list, you need to make sure that you include the type it is. It's a typed. A list is a typed collection, whereas an array list is an untyped collection, right? You just define it like this, an array list, and then you can just add elements to that array list, right? And the reason this says less safe is because you could create this array list, and you could put something in there. Let's say you're using this array list as you're expecting this array list to be all numbers, but since you didn't use a list like this to ensure that each one of these is always going to be a certain type. Let's say you did that, and for some reason a string got put in there, then all of a sudden you could have something blow up in your code because it tried to use maybe a string, and it thought it was a number, but tried to do something on that string that it's not able to do, right? And that's why it's saying it's less safe. Okay. Common collection methods. We looked at the list. Remember, add T item adds an element to the end of the list. Yep. Count gets the number of elements in the list. Use a count to get the number of elements in the list. And when you want to remove at a certain point, you have to use a remove at and use the index. And, just real quick, so you're thinking, well, okay, I have this big long list. Well, how do I know the index? Well, maybe you'd have to do something like you'd use some kind of a search or something, and you search for some certain thing in that list, and you say, okay, find this and return me the index. It'll find that, return the index, and then you could use the index to remove it. Okay, that's kind of a little quick, explanation of how possibly you would do that. So, as we said, a stack is LIFO, meaning last in, first out. When you push in stacks, you use what's called push, pop, and peek. You push an item, adds an element to the top of the stack, right? So it's always the top of the stack. The top of the stack is always the last thing, right? So you're always pushing it to the last. Pop removes and returns the top element from the stack. Peek returns the top element without removing it. Okay. And here's a queue. And a queue, remember, queue is first in, first out. And you use this in queue. It adds an element to the back of the queue, right? Yeah, I probably said that a little wrong here. So basically, it's going to add an element. In a stack, you look at a stack being like a rectangular stack, or so stack is the top of the stack, right? It's not really the back, it's the top of the stack, okay? Whereas a queue, it's first in, first out, but when you add something, you're adding something to the end of it, right? So end queue, so adds an element to the back of the queue, right? DQ removes and returns the element at the front of the queue. Remove and returns the element at the front of the queue. Peek returns the element at the front of the queue without removing it. Peek just looks at it. Okay. Dictionary stores key value pairs. And then you can add a new key value pair. And then you can ask, you can check a whole dictionary. Does, this contain this key? And then we have try get value, attempts to get the value associated with a key, right? So sometimes, I think I mentioned this just a little bit ago. So, like a lot of times in an array list, if, you might have to search through a lot of elements to find something. Well, where you're using key values, especially if you know how to, if for some reason the key, like you're saying, okay, I need the key, I need the name of the student with this student ID. Boom! If you got the student ID, you've got the key, and you can grab the value very quickly, right? So much more efficient. Okay. Here's some examples when to use when you use an array list. Use an array list when you need fast random access to data in a single container, and you aren't frequently inserting or removing elements. And this is just basically telling you from probably a performance perspective, right? If you're frequently inserting or removing elements, array list is probably not the best one to use, okay? Array list can store multiple data types. So, that's the important thing. We looked at that, how we added an integer and added a string, so it could be multiple data types. And like it said earlier, it's a little less safe because you could be actually using something in that array list thinking it's one thing and it's not. So that's why a lot of times when you're doing something where that you need this to be a number, that's where you want to use a typed one like the list, right? Where you give it a type of an int or something like that, right? Queue, when to use a queue, when you need to process tasks in order they were added. Queues are useful for temporary storage of information and are based on first in, first out model. Stack uses a stack when you need to access elements in last in, first out manner. Stacks are useful for temporary storage of information and are good for reverse processing tasks like program compilation. That's what we were kind of talking about, right? Stacks can also be used for evaluating expressions, backtracking, memory management. So I won't go through all of these, but here's some practice questions, and here's the answers to those questions. Here's some characters, miscellaneous. Yeah, I might remove some of this. Fixed size once created. I think that's good. I don't think we kind of went through these. I think I'm just going to remove that. But I'm going to go through this a little bit more. And so I'm going to make this available. This chapter 8. This will be chapter 8 study guide for you for the written test. That should be helpful in that. So here, so I think we'll just go ahead and continue on here. About an hour after our last break, but I'll just go ahead and go through this lab stuff, and then we'll call it a day, and go from there on that. Okay, so here's the chapter 8 labs. Can I make this bigger? Yes. So the first lab, write these C# win forms. And here you can notice it talks about parallel arrays, right? So like I showed you an example of a parallel array where you had a student name, a student ID, right? And it had a phone number. In this case, you're going to have two arrays, right? You're going to have one for a zip code and one for a delivery charge, right? So that the zip code array at the 0 position, right? Subscript 0 is going to be this one. At subscript 0, the position at subscript 0 for this one. For the delivery charge, this is 0, right? Will be 20, right? And so that's how you can, based on this zip code, you can get the delivery charge, right? Okay. So basically, yeah, you're going to put a zip code in here, calculate, and get and you'll have the delivery charge. So pretty simple, really. I know the array stuff's new, but this is pretty simple as far as arrays are concerned. You're going to You're going to loop through your array until you can find this. Let's see, does it say work? There's different ways to do this. It doesn't provide like a contains. Sometimes you're going to want to loop and see if something contains some certain string, and based on that, right? But this should be just pretty basic, where you're just going to loop through your array till you find this, so you'll know your index, right? You'll know your index, which would be like for 13 on this example, your index would be 0, 1, 2, 3, 4. And then you could say the one at fourth location is going to be 10, right? And this is what's showing you here. So that should not be too much of a problem for you. Here we're doing the same thing. 1 to 2 nights. Night stayed. Yeah, you might have to think through this one a little bit more. Night stayed 1 to 2 nights. Yeah. So this one, well, because you're not putting in this whole value here, you're probably going to do contains here. If this contains a 4, right? So look into that a little bit. So in this case, if this, you're going to loop through these, and if this contains a 4, then you're going to, or contains this maybe. Yeah. Then you're going to want to say, then you're going to use this one. So, all right, that's that. Right, C#, searchable database. So here it is showing you string contains. And string lower is important too, especially, especially when you're doing a comparison. You want to. Because sometimes you might have something that has uppercase and sometimes lowercase. It's best to get what you're comparing against, the two different things you're comparing against each other. Make sure that they're both in the same, use the same case. So best to use like 2 lowercase on both of them before you compare them. Okay. So, okay, I don't see. The search should be in case insensitive, meaning, yeah. So if you put all uppercase letters, then when you get to your program, you're going to just take whatever's entered in here, make it lowercase, right? And then you're going to take whatever's in this value and make this all lowercase, just to make sure when you're doing a compare, right? Well, you're basically going to have to do that searching contains. Yeah. So yeah, you have to be careful, because if you try to do a contains on this, and this is going to upper C, this has you have to think about that. It's not going to match. Upper C is not going to match lower C, so you're just going to have to make sure that you've got that covered. Movie database. Okay. Okay. Yeah, that one might be a little more challenge for you. But I don't think they're too, that one's maybe a little more challenging. Once you learn how to do the contains and you play with that, make sure the things are the same case. A lot of these won't be a problem. This movie database shouldn't be a problem. You're just going to have multiple. So here, you've got 3 arrays: name, publisher, and price. So has anybody got any questions about anything here? about arrays in general, about this lab assignment. Tomorrow I'll make the hands-on test available early in the morning, and we'll go through that. It's not too bad. It'd be a good idea if you've got time to today to work on these labs a little bit. It'll just make your life a lot easier for the hands-on test tomorrow.